Okay, today we are going to talk about 3.7 implicit differentiation. So this is implicit as opposed to explicit when it's solved for y. So it's different from explicit when solved for y. Your objective is to be able to solve problems involving differentiating implicitly, second derivatives, and slopes, tangents, and normals. So while we're studying this, most of the functions we've dealt with so far have been described by an equation of the form y equal f of x that expresses y explicitly in terms of the variable x. You've learned various rules for differentiating functions defined this way. A different situation occurs when you have an equation such as x cubed plus y cubed minus 9xy equal to 0. Or if you had y squared minus x equals 0, or x squared plus y squared minus 25 equals 0. This last one would have been an equation of a circle with radius 5. But you notice in all of these, x and y are on the same side of the equation. These equations define an implicit relation between the variables x and y, meaning that a value of x determines one or more values of y, even though we don't have a simple formula for the y values. So we begin with examples involving familiar equations that we can solve for y as a function of x, and then calculate dy dx or y prime in the usual way. Then we differentiate the equations implicitly and find the derivative. We will see that the two methods give the same answer, and see examples on page 149. So on 149, in our first example, it says find dy dx if y squared equal x. So we have two differentiable functions, one of them the square root of x and the other the negative square root of x. This is when we solve for y by square root on both sides. And so we know how to calculate the derivative for each of those if x is greater than 0, which means that it would be defined underneath the radicand. So basically you have to have values x greater than 0 for this to work. It can't be x greater than or equal to 0, because if it were 0, you'd have 2 times 0 in your denominator, which is 0, and 1 over 0 is also undefined. So suppose we knew that y squared equal x defined it as only one version without knowing exactly what the functions were. Can we still find dy dx? And they are saying yes. To find dy dx, differentiate both sides of the equation with respect to x, and treat y equal f of x as a differentiable function. So the first thing is, we've got y squared equal x, and we want to take the derivative of y squared, and that's 2y dy dx, which is like 2y y prime. And then you take the derivative of the right side, and you get 1. Derivative of x is 1. So then we solve for dy dx by dividing by 2y, so we get 1 over 2y. And then on the other one, this one formula gives the derivative that we calculated for both explicit ones, and they're showing you if you have 1 over 2y1, that's really 1 over 2 square root of x, because y was the positive square root of x in this case, and then negative square root of x on this case. So that is an example. Number 4, differentiate both sides of the equation with respect to x, treating y as a differentiable function. Then we want to collect the terms with dy dx on one side and solve for dy dx. For ones of higher order, you can also use implicit differentiation, and it's showing you example 4. So on this example, you have d squared y over dx squared, with your function being 2x cubed minus 3y squared equal 8. So again, we want to take the derivative of both sides. So when we take the derivative of 2x cubed, it's simply 6x squared, because we do 3 times 2 and then decrease the power. And then when we take the derivative of negative 3y squared, you take your negative 3 times 2, which is negative 6. Then you put y, and then the extra thing is you need y prime. On this one, you didn't need to do x prime because it was already understood to be 1. But on this one, you need y prime. And then when you take the derivative of any constant, you get 0. So then what they did is they solved for y prime. They moved the 6x squared over, divided the 6 and negative 6, and ended up with x squared over y. And then you want to use your quotient rule. So that's where you have your v times u prime minus u times v prime all over v squared. And they did that and then simplified it, and then they substituted it in for y prime, and they got the second derivative. Okay, and then for the lenses, tangent lines, and normal lines, just talking about that related to physics. In the law that describes how light changes direction, as it enters a lens, the important angles are the angles the light makes with the line perpendicular to the surface of the lens at the point of entry. This line is called the normal at the point of entry. The normal is the line perpendicular, which is also said to be orthogonal. To the tangent of the profile curve at the point of entry. See example 5. So here you have a lens, and the normal line is perpendicular at the point of tangency. Remember, a tangent line touches the point, the lens in this case, at one point. And there's your perpendicular line. Okay, so now let's start the problems. finish up the header later. For number 1, we have x squared y plus xy squared equals 6. Okay, so for your first step, what you want to do, this is step 1, is take your derivative of x squared, and so that's 2x, keep the y how it was, plus keep the x squared how it was, and take the derivative of y, which is y prime. So that's using your product rule. Then we've got to do that on this one as well. So take the derivative of x as 1 times y squared plus the derivative of y squared would be 2y y prime, and then we need to multiply by x, and then set this equal to 0 because the derivative of 6 is 0. So our first step is going to be keep all the y prime terms on the left. So y prime, and I'm factoring that out, we get x squared plus 2 yx, but we're going to say xy. And we're moving this term over, so this would be negative 2xy, and we're moving this term over, so that'd be the minus y squared. And that was step 2. Factor out your y prime, and then solve for y prime. So you're going to have negative 2xy minus y squared in your numerator, and then x squared plus 2xy in your denominator. So that's your first one. Your next one is number 3. We have 2xy plus y squared equal x plus y. So again, for step 1, take your derivative of 2x and you get 2, keep the y how it was, plus take 2x times the derivative of y, which is y prime. So both of those are from your first term. Then we need the derivative of y squared, which would be 2y y prime. And then take the derivative of x, which is just 1, and take the derivative of y, which is y prime. So now we want to factor out the y prime, and we get 2x plus 2y just noticed we have a y prime here, so let me cross this out and make this minus 1. Basically just moving this to this side and factoring out a y prime. So we have 2x plus 2y minus 1, and then equal to 1 minus 2y. Then we just divide by everything here, and so you have y prime equal 1 minus 2y over 2x plus 2y minus 1. So again, we factored out the y prime. We had to move this term over to this side. And when we factored that out, it changed to negative 1. And then equal to 1 minus 2y. And then from there, kept this as your numerator and made this your denominator. Okay, number 5. This one's a bit trickier, so let's just see how this goes. We have x squared times x minus y squared equal to x squared minus y squared. So the first thing is let's keep the x squared how it is and take the derivative of this one. So keeping the x squared, and then the derivative of this expression would be 2 times that inside. Then you need to take the derivative of the inside using your chain rule like we did previously, and the derivative of x would be 1, and the derivative of negative y would be minus y prime. So that's with keeping x squared as it was. Now we're going to keep x minus y squared as it was. And then the derivative of x squared would be 2x. Okay, then we need the derivative of x squared, which would be 2x, minus the derivative of y squared, be 2y, y prime. Again, whenever you're taking the derivative of y, we need a y prime, or dy dx. From there, we need to multiply things out. You have a lot of terms to multiply out. So we'll start with 2x squared. And we have x minus y looks like what we're doing is distributing. So they're trying to save a step and put this with a minus sign here and then a y prime, and then they are adding 2y y prime and then moving more terms. We're going to keep the 2x where it is. And we're moving a 2x squared x minus y and a minus 2x x minus y squared. Okay, so basically what they did is they distributed this out and they kept the y prime term on the left. And so it's basically this times the negative y prime. So that's how they got that. And then they moved this term over to the left side. Then they just dropped down this term. And then when they distributed this to the 1, then they moved it to the right because it didn't have a y prime. And then this last one they had to move over. So this plus 2x turned into a minus 2x. So again, we needed to keep y prime on the left. From there, factor out your y prime. So we have negative 2x squared x minus y plus 2y equals all of that. Looks like what we're going to do is factor out a 2x because all of these have a 2x. And so we get 1 minus x, x minus y, minus x minus y squared. Okay, from there what they want to do is divide this. And so we have 2x, 1 minus x, x minus y, minus x minus y squared. All of that divided by negative 2x squared, x minus y plus 2y. So the first step that we're going to do to simplify this is to cancel out the 2 with both of these. Because you could have thought of factoring out a 2 and then dividing it. But that's going to be our first step. So we get x and then 1 minus x, x minus y, minus x minus y squared, all over. They're going to put this y first, so it'll be y minus x squared, x minus y. Then they want to start distributing this and expanding it. So negative x times x is minus x squared. Minus x times minus y is plus xy. So that took care of those. Now we need a minus sign. And when we go with x minus y squared, that's going to look like x squared minus 2xy plus y squared. And then let's distribute this, so we get minus x cubed plus x squared y. Now what we need to do is, well, we have a bracket to close from that. We've got to change some signs and cancel some things out and rearrange it. So we get x, and then one minus x squared plus xy minus x squared plus 2xy minus y squared. So that's basically from distributing this minus sign throughout. And then on this, we want to put the x squared y first. So we're going to have x squared y minus x cubed plus y. Then we just need to combine a couple of terms. So negative x squared minus x squared would be negative 2x squared. But we also want to distribute. So first we're going to say x times 1 is x minus, then this would have been 2x squared, but then we're distributing x, so it's cubed. And then x times xy is x squared y, and x times this would be 2x squared y. In other words, if you just do xy plus 2xy, you get 3xy, but then we've got to square it. So 3x squared y. So that's basically combining this with this, turns into 3, and then an extra x. And then this turns into minus xy squared, and then this is your denominator, x squared y minus x cubed plus y. And that's our answer. So this was step 5, step 6, step 7, and finally step 8. Very important that you distribute properly and combine your like terms. Okay, so there's 1, 3, and 5. Number 7 is next. And on this one, it says y squared equal x minus 1 over x plus 1. So this one we're going to have to use u over v using our quotient rule. So our derivative of y squared would be 2y and then y prime. And then for this part, we need to take our, it's basically v times u prime minus u times v prime all over v squared. This is your quotient rule. And so we take our x plus 1 multiply by the derivative of x minus 1, which would just be 1, minus u, which is x minus 1, times the derivative of the denominator, which is also 1, over x plus 1 squared. So what this gives you, just keep it the way it is, 2y, y prime. This gives you x plus 1 minus x plus 1, which then in turn, x minus x cancels and you get 1 plus 1 is 2. Okay, so all of these were simplification steps on the right side. Now our goal is still to get y prime by itself, so we have to divide by 2y. And so the 2 over 2 cancels, so we get 1, and then we bring our y over, and then x plus 1 squared. And that's our answer. Okay, now number 9. On this one, you have x equals secant y. So you take your derivative of x, which is 1, and your derivative of secant, which is secant tangent, and keep the same y for there. And also, since we're taking the derivative of y, we need a y prime there. At that step, we're going to basically divide by the secant tangent. So we're going to have y prime equal 1 over secant y tan y. So this is where it'd be really good for you to remember your trig identities. 1 over secant y is the same as cosine y. And 1 over tan would be cotan. But if we keep it in terms of sine and cosine, this would have been 1 over sine over cosine, so then you get sine y over cosine y. One over that. And so that's like saying cosine y times cosine y over sine y. And so you get cosine squared y over sine y. Okay, so this is one form of the answer, cosine times cosine over sine. The other answer would simply be cosine y times cotan y. And this would be the preferred way because they want to use 1 over tan just as cosine. And so if you want to be very simple, and do this in a different color, you can go from this step directly to this step. if you want to. And so basically 1 over secant would be cosine, 1 over tan would be cotan. And so you could skip directly to that part. Okay, number 11. On this one, we have x plus tan xy equal to 0. So first take your derivative of x and you get 1. Take your derivative of tangent and it's secant squared. And then keep the same xy. Then for the part after that, you have to take the derivative of xy from the product rule. And so the derivative of x would be 1. 1 times y is y. And then keep the x like it was and take the derivative of y, which is y prime. And that's equal to 0. So what they want to do now is move this 1 to this side, and they want to work on distributing and keeping the y prime term on the left. So let's just do an extra step. Stick a y in front of this. Okay, so basically we're distributing those, and now keep this one where it is. We have x secant squared xy equal to -1 minus y secant squared xy. So basically just move this over here and move these two terms over. And then you pretty much have the answer. You have -1 minus y secant squared xy, all of that over x secant squared xy. So then what they're doing is they're splitting up that into different parts. And they get -1 over x secant squared xy minus y over x. So basically having that part. The reason why they're doing that is because if you have 1 over secant squared, we know that's equivalent to cosine squared. So we have negative cosine squared of xy over x minus y over x, and then those can just be combined. So you end up with negative cosine squared xy minus y, all of that over x. So the whole purpose of this is to use an easier trig function. Okay, that's going to be a good stopping point for this video.